Well, hello everybody. Welcome back to Algebra 1, Chapter 6. We're going to talk about systems of equations. Thing that we're going to talk about with systems of equations is graphing them. Systems of equations are when we've got two equations that we're worrying about. So notice at the very first review problem, because we are going back to things you know how to do, which is graphing. It says to sketch each graph on the same coordinate plane. So my first equation, y equals negative 1/3 x plus 4. We're going to go to our oldie but goodie. We know that our b is 4, our slope is negative 1/3, which means I'm going to put a point on the y-axis at 4, go down 1 and over 3, down 1 and over 3. When we did inequalities, remember we had to worry about solid or dashed. This is an equal sign, so we just connect these dots with a nice neat line. Put arrows on both ends, we've got that done. The second equation, notice 2x plus 2y equals 8, that is not in mx plus b form. So remember, it's always easiest to graph when it's that way. So I'm going to subtract 2x from both sides, which means that I've got 2y equals, you could write it as 8 minus 2x or negative 2x plus 8, which is how I like to write it. Divide by 2 because I want to get my y by itself. So now we're going to graph the equation y equals negative 1x plus 4. So now if I look at my m and my b for graphing, I know that my m is negative 1, or negative 1 over 1. I know that my b is 4. So I'm going to do the same thing. I'm going to put a point at 4. I'm going to use down 1 over 1 for my slope. I'm going to connect those guys with a nice neat line. Whoops. Whoa. That's not what I was trying to do. Do that again. There we go. So all I really did here was graph two lines on the same plane, but notice my two lines intersect. So we are going to use this to find solutions. Notice right here it says, determine the number of solutions and solve the system. So here's what you need to know. First of all, system of equations is when you've got two or more equations. And the solution is an ordered pair that satisfies both equations. Satisfies makes it true, or we could actually look for the point where the lines intersect. So in this case, the one that we just graphed, right here, my two lines intersect. That is my solution. I'm going to name it with an ordered pair. It looks like it's over 0, up 4. Came out to a nice, neat graph. And actually, they both have a b of 4, right? So it only makes sense. So my point where my lines intersect is going to be my solution. So the solution for that example was 0, 4. If I put 0, 4 into either one of those equations, I would get a true statement. I would get like 4 equals 4 or 8 equals 8. There is, however, times where they might not intersect. So we've got three things that could happen. Option number 1 is the lines intersect, which means we've got one solution because the one point where they intersect is the solution. And there's terminology for that. That's called a consistent and independent system. We could graph two lines and they end up on exactly the same line. They're just overlapping each other. So that means every single ordered pair from one line will be the same every single ordered pair for the other line, which means there's infinitely many solutions. That's called consistent and dependent. The lines depend on each other to be exactly the same. And our third possibility that could happen is the lines will be parallel. Well, if we mention that the solution is where they intersect, Will parallel lines ever intersect? So we'd say there's no solution. Feel free to use our no solution symbol. That is called an inconsistent system if we're going to be technical about it. So those are our options. So let's take a look at already pre-graphed. I want to do this because I'm going to give you some like this in the work, and I want you to see the graphing work is done. We just need to look at what the answers are. So how many solutions there are. How many solutions? Oh, don't answer that. All right, so letter 1 or number 1A. We have got y is equal to negative 2x minus 5. Well, the work's done for us over here. So right here is my negative 2x minus 5, this red line. It also asks for y equals x minus 5. Well, if my work is done, here's this purple y equals x minus 5. If I look at this purple line and this red line, do those two lines have one solution, no solution, or infinitely many solutions? They've got one solution, right? Right there is where those two lines intersect. So I'd say one solution. Let's really be technical and let's tell what the ordered pair of that one solution is. It looks to me like this is the origin, because I can tell by the arrows on the ends of the axes. So it looks like it's at 0, negative 5. It's not always going to be at 0 something. So letter B, it asks for how many solutions for y equals negative 2x minus 5. So still this red line over here. And y equals negative 2x plus 3. That's this green one over here. What do you notice about these two lines? Do they have one solution, no solution, or infinitely many solutions? I notice they have the same m. If you think back a while ago, if the slope is the same, they are parallel lines, which means there is no solution. I'll put parallel. So use what you know. If the slopes are the same, you know they're parallel. Parallel lines never intersect. I'm getting the hang of these ones. My guess is what the answer is for the third one. If we look at the equations, y equals 2x plus 3, graphed over here this blue line. Y equals x minus 5, graphed with the purple line, blue line. Ooh, this is a good one. Do these guys have one solution, no solution, or infinitely many? They don't intersect on my graph, but if I extended the graph, would they intersect? They would, right? It does have one solution. Don't forget, that's why we put arrows on the end of each line. We can't name that solution because it would be somewhere down here off the graph, and we don't know where that is. All right, so let's do an example. First of all, the directions on these guys are going to read something like solve each system of equations by graphing. Determine whether the system has one solution, no solution, or infinitely many. If it has one solution, name it. Well, the one thing that I wanted to say here, there we go, is you need to use graph paper. You have to. You must use graph paper to do this. Because if your line, and I recommend rulers as well, or a straight edge of some sort, because if your line is slightly messy, if your grid marks are slightly off, that's going to mess up your solution. So you have to be very precise when you do these. So let's do a quick graph here. Number 2, we've got y equals negative x plus 8 and y equals 4x minus 7. Well, this is really nice because these guys are both in mx plus b form, so there's no work to be done besides graphing. So for this top one right here, my b is 8. My slope is negative 1. I'm going fast through this because I feel like at this point, if you don't know how to graph, you need to get in here and ask me questions. Sometimes I put extra dots on here because I want to see where they actually, the nice neat point where they intersect. This second one, my b is negative 7 and my slope is 4. So I'm going to go down negative 7 and then I'm going to go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 3, 4 over 1, and I could keep going. I'm going to draw myself in a nice neat line for this one. Whoa, that was supposed to be nice and neat. Please use a ruler or a straight edge. However, does this system of equations have one solution, no solution, or infinitely many? It's got one solution, right? I see that point where those two lines intersect. That point is right there. It says if the system has one solution, name it. Not like Mrs. Stauffer or Jacob. Name it as far as an ordered pair xy. So it looks to me like it's over 1, 2, 3, 1, 2, 3, 4, 5. And that is how we solve a system of equations by graphing. So we could run through and talk about graphing, but really what it comes down to is you knowing how to graph and then putting those two equations, all on one graph. So I think that we don't need to do another example. We'll talk about these. I'm not going to worry about the consistent and dependent. We can look those things up. I'm going to worry about the graphing and seeing that the lines intersect, or if they're the same line, or if they're parallel. So does it have one solution? Can you name it? Does it have no solutions or infinitely many? So please answer this question. What is a system of equations? And what's a solution and where do you find it? You don't have to write out the question, just write out the answers to that. And I did put some graph paper, there we go, on your practice problem because I want you to solve that system. Please notice those are both in y equals mx plus b. I didn't even make a ton of work for you. They're ready to graph. You can just find your y-intercept and use your slope to go from there. That is it for section 6-1. Have fun graphing, bring your questions to class, and we'll see you next time.